Okay, so 2.8 is about linear and absolute value inequalities. You've probably seen linear inequalities whenever you took Algebra 1, but if not, I will definitely teach it to you now. So, a linear inequality, okay, is an inequality where with two variables whose graph is a region of the coordinate plane bounded by a line. The line is the boundary of the graph. The boundary separates the coordinate into two half planes, one of which consists of the solutions of the inequality. So on this, you're going to have two types of these graphs. You're going to have either one with a solid line or a dashed line. We'll talk about that in a second. So this one right here would be a dashed line. This would be the solid one, obviously. And then they're going to be shaded. And I'm going to teach you how to know which side to shade. So you shade either this part or this part, whichever, either above or below or left or right, however you want to think about it. So what this means is instead of an equal sign on these graphs, they're going to have an inequality. So, and here are some inequalities right here. So what that means, since it's an inequality, it's not just an equal sign where there's one point or several points that will fit on it. There's a ton, which I guess either way you look at it, there's a ton on a line too, because it goes on forever. But so on this one right here, if I were to pick any point in this shaded region and plug it into the inequality, it would be true. Okay? So before we get into all that stuff, let's just talk about when to know whether it's going to be a shaded line or a dashed line. So whenever you have less than or equal to or greater than or equal to, it is a solid line. Okay? If it's less than or greater than, it's dashed. So it looks something like this. Okay? So the first steps whenever you're doing this are kind of the same as when you just graph a regular line, depending upon which way they give you the equation. So you graph the function normally, and then you need to know if it's going to be solid or dashed line before you connect your lines, and then pick a test point and plug it in, and I'll show you how to do that. If the test point is true, and you'll shade that side that the test point is in. If it is not true, then you'll shade the opposite side. Okay, let's just talk letter A. Is this going to be solid or dashed? Well, this is going to be dashed, right? Because it's less than. Okay, so this is already in slope-intercept form for you. So remember, this is your y-intercept, and your slope would be the number in front of the x. So in this case, just 1. So you go to the y-intercept, put a point there at 2, and then go up 1 over 1 a few times. Now, dashed lines can be a pain in the butt. If you're on Notability, you can toggle on the types of lines it draws, and it'll do it for you. Sorry about that. So anyway, Notability will make a dashed line for you. So let's see how well I can do. Okay. All right, not too bad. So that's my dashed line. So now I need to pick a test point. If you can, I would always pick 0, 0. The only time you cannot pick 0, 0 is if the line is on that point. Okay, so we have to pick some point on the line, or that is not on the line. So 0, 0 is the easiest to plug in because it's literally zeros and it makes your life a lot easier. So remember that coordinate is 0, 0, so the x is 0 and the y is 0, right? So we are going to plug it in, the zeros for the x and y, so is 0 less than x plus 2. Oh, sorry, not x. Is 0 less than 0 plus 2. Clean it up a little bit. Is 0 less than 2? Yes, it is. Since that point is true and it works in this inequality, then I'm going to shade this whole half plane right here as best I can. I'm not going to take all day, just a little bit. Okay, so that's how you do it. So let me show you what a point, if I would have picked another point that wasn't true, like over here. Let's say this point right here, oops. This is a not true point because obviously it's not in our shaded plane. So that point right there is what? 0, 6. Okay, so I'm going to plug in 0 for my x and 6 for my y. So is 6 less than 0 plus 2? Is 6 less than 2? No, it's not, which makes sense because that's not our shaded region. So that's how it kind of works. If you need to pick a different point, you can. It's not a big deal, but just pick 0, 0 if you can't, if it's not on the line, because it's going to make your life easier. Okay, here's another one. We have the y-intercept of -2. Then your slope is going to be 1/3, so up 1, right 3, up 1, right 3 a few times. Now this one will be a solid line because it is, I'll just write that up there, solid, because of that inequality is greater than or equal to. Okay, let's try it one more time. All right, so what test point am I gonna pick? You're right, 0, 0. Let's do it in green. Okay, so is 0 greater than or equal to 1/3 times 0 minus 2? Okay, so 1/3 times 0 is 0. So 0 minus 2 would be -2. Over here, is 0 greater than or equal to -2? The answer is yes, that works. So we're going to shade that part of, or that half plane. Okay, so let's go on to the next one. So we have the y-intercept is +3. And then we're going to go down to right 1 because it's a -2 slope. Do that a few times. This will be a dashed line. And you don't have to write that. I'm just trying to do it for your notes. So let's see how my dashed lines is looking. Terrible, but I'm going to make it work. Okay, so looks like we can pick 0, 0 again. So if I have 0 is less than -2 times 0 plus 3. So 0, or sorry, I said less than, I meant greater than. Is 0 greater than 3? No, it is not. So nope. So that means since that point does not work, we're going to shade in the opposite direction. If you would like to be super sure, you could pick a point in this region and try it and see if it works. But you definitely don't have to. Just know if it fails, shade the opposite way. Okay, if you want, pause the video, try this one by yourself. This y-intercept is at -3. This is, and then it goes up 3 over 1. This would be a solid line. I'm gonna pick the point 0, 0. Is 0 less than or equal to 3 times 0 minus 3? Is 0 less than or equal to -3? The answer is no. So we are going to shade on the opposite side again. All right, now this they give it to you in standard form. No big deal, you can still do it. Do you remember how to graph in standard form? This is the one where you find the intercepts. So let's just do it. So the x-intercept is when y equals 0. So we're going to do 3x minus 4 times 0. You don't need the inequality because we're just finding the intercepts. So I'm going to put an equal sign. Doesn't matter. If you want to put the inequality, it's okay. It doesn't affect anything. So this would be 3x equals 12. Divide by 3. So your x-intercept is 4. Let's find the y-intercept. So that's when x. So that would be 3 times 0 minus 4y equals 12. -4y equals 12. Divide by -4. Don't forget the negative. So y equals -3. Okay, so my x-intercept is at 4, so I'll mark that. My y-intercept is at -3. This will be a solid line, right? Because that has the greater than or equal to. Try that again. So even though this is a little bit different, you still pick your test point the exact same way. So I'm going to pick 0, 0. is, I'll write it up here because I'm running out of space. 3 times 0 minus 4 times 0 greater than or equal to 12. AKA is 0 greater than or equal to 12. The answer is absolutely not, no. So therefore we need to shade below it on the other side. Okay, last one of these, same exact thing. If you want to try to pause the video, go for it. So I got to find my x-intercept. So that's negative 5x plus 10 times 0 equals 20. So negative 5x equals 20. Divide by negative 5. X is negative 4. Your y-intercept is negative 5 times 0 plus 10y equals 20. 10y equals 20, divide by 10, so y equals 2. Okay, so y equals 2, x equals negative 4. This will be a dashed line. Okay, and then let's pick our test point, 0, 0. Let's do it over to the side. So is negative 5 times 0 plus 10 times 0 less than 20. Oops. So is 0 less than 20? Check, it is. So then that means we need to shade on that side. Cool. All right, now, just when you thought, oh, this isn't that bad, let's throw some absolute values in there. Just trust me, it's okay. So it's going to be the exact same as whenever we graphed absolute values. It's just you got to pay attention to whether it's a solid or dashed line, and whether which side you need to shade on. Okay, so y is less than the absolute value of x. Well, the absolute value of x is the parent function, right? So we have, oops, here, here. Okay, so that's just the regular, no shifts, no strengths or stretches, no reflections, just the parent function. Okay, this will be dashed lines because of the inequalities. Oops, not solid. Okay. These are real bad, I'm sorry. Okay, I'm gonna pick a point. Let's pick this point right here. So that point right there is 0, 4. Notice I did not pick 0, 0 because I can't, right? That's where your vertex is. You can't do it. It's on the line. So you're going to have to pick a different point. So I need to plug in is 4 less than the absolute value of x, which in this case is 0. So is 4 less than 0? No, it is not. Therefore, we need to shade on the opposite side. Okay. Ooh, this one has a stretch and a reflection. Whew, okay, let's talk about this. This has the negative out front, means it's a reflection, right? And then the 2 means a stretch by scale factor 2. And then the plus 4 on the outside means up 4. Okay, let's do it. So it looks like it's just shifted up 4. That's not bad. Okay, so positive 4. Then it's a reflection, so it's upside down, and the slopes of the lines are negative 2 and positive 2. So I need to go down to left 1 and right 1. Okay. Looks like this is a solid line. Sweet. So that's the graph. All right, now we just need to figure out where we shade. I'm going to pick 0, 0. Is 0 greater than or equal to negative 2 absolute value of 0 plus 4? So absolute value of 0 is 0, and then negative 2 times that is still 0. So is 0 greater than or equal to positive 4? The answer is no. So we are going to have to shade in the opposite direction. Alrighty. Okay, so that is all I am gonna do for inequalities. I know there's a little bit down here, but we're just not gonna do that because it doesn't come up on the homework. I thought it did. So, all right, that is it. Thanks for watching. Have a great rest of your day.